Good morning, everybody. Can you hear me? Can you hear me?
Yes, sir.
Okay. Welcome back. So last time we talked, we proved that theorem regarding eigenvalues and eigenvectors, and towards the end, I also showed you how to compute the eigenvectors. Today, I will show you one simple method of computing the eigenvectors, and we'll also do some numerical wherein we'll be obtaining the eigenvectors for a given vector and using that to obtain the state transition matrix. So our topic is today is 14. We'll talk about one more method of computation of eigenvectors. So as you know, we have this. We were basically trying to evaluate the state transition matrix, and one of the methods of evaluating the state transition matrix I told you is exclusive transformations, wherein we transform the matrix A into diagonal form. And for that, we have seen that we need to compute the eigenvectors. In eigenvectors computation, one method I have shown you by solving the set of simultaneous equations, which sometimes becomes a bit tedious. I'll show you one simple method of evaluating the eigenvectors. You know that as per the definition of eigenvalues and eigenvectors, we have lambda I minus A into Vi equal to 0. This we have already seen that this is the definition of eigenvalues and eigenvectors. This is by definition. I call this equation 1. Now from matrix theory, we know that for any square matrix M, we have M into adjoint of M equal to determinant of M into I. Isn't it? M into adjoint of M is equal to determinant of M into I, because you know that M inverse equal to M inverse is equal to adjoint of M upon determinant of M. Or we can write M inverse into determinant of M is equal to adjoint of M. So if I pre-multiply by M, I get like this. So this and this goes. I have determinant of M into I is equal to M into adjoint of M. Isn't it? So I have this property of adjoint. Actually, this doesn't follow from inverse. This is one result in matrix theory that M into adjoint of M, that's equal to determinant of M into I. Now let M is equal to lambda I minus A. Because this is also a square matrix, then I can write lambda I minus A into adjoint of lambda I minus A is equal to determinant of lambda I minus A into I. Is it okay? On matrix theory, for any square matrix M, we have this result. And if I put M is equal to lambda I minus A in this standard result, I'll get lambda I minus A into adjoint of lambda I minus A is equal to determinant of lambda I minus A into I. Or I can write lambda I minus A into adjoint of lambda I minus A is equal to, what is this equal to? What is determinant of lambda I minus A equal to? Yes, I am waiting for your responses. What is determinant of lambda I minus A equal to?
Characteristic equation, sir.
No, in the characteristic equation, if you substitute, because lambda I actually is the eigenvalue. In the characteristic equation, if you substitute eigenvalue for lambda, what will you get?
0.
0. So this is actually equal to 0, isn't it? It's a 0 vector actually. Not a scalar 0, it's a 0 vector. It's multiplied by I. Actually, this is scalar 0, but when you multiply it by I, it will become it will not remain a scalar 0, it will become a vector 0. So this is it. Now let me call this as equation 2. If you compare 1 and 2, if you compare this equation 1 and equation 2, so you have got lambda I minus A here, you have got lambda I minus A here. Here you have Vi, which is the eigenvector, and instead of that, we have got adjoint of lambda I minus A. Adjoint of lambda I minus A actually will be a matrix, which will have its columns. So this Vi actually, it is an eigenvector corresponding to lambda I. If I compare equation 1 and 2, comparing equation 1 and 2, we can write that, we can conclude that, from here that this Vi, actually, this eigenvector Vi, when you compare this equation and this equation, you can see here you have got lambda I minus A. Here also you have got lambda I minus A. Then instead here you have Vi. Vi is an eigenvector. And here you have adjoint of lambda I minus A. You find that this eigenvector is actually any column of this adjoint matrix. You will have this adjoint matrix which will have all the columns linearly independent by virtue of the property of eigenvalues and eigenvectors. Because this is basically the characteristic equation, and in that characteristic equation you are substituting eigenvalue for lambda. So you'll find that this Vi actually is, so from this we can conclude that Vi is, that is the eigenvector. Eigenvector Vi is proportional to any non-zero column of adjoint of lambda I minus. Zero तो हो नहीं सकता, eigenvector cannot be a zero vector because eigenvectors are linearly independent, and for a linearly independent set of vectors you cannot have a zero vector because zero vector is actually a dependent vector. So if you compare this equation and this equation, you can find that this Vi actually, because this lambda I minus A is actually a matrix, Vi is a vector. So this lambda I minus A, this Vi actually is proportional to any non-zero column of this lambda I minus A. We will find that once we will see some examples. We will find that this lambda I minus a will have all the columns linearly independent. So we can take any column of this adjoint of lambda I minus a, and that will give the eigenvector corresponding to that lambda I. So this gives an easy method for evaluating computing the eigenvectors. तो अब अगर आप किसी eigenvector आपको compute करने हैं किसी भी matrix A के, तो procedure क्या है? तो पहले आप adjoint of lambda I minus a. If I illustrate the procedure, so procedure for computing the eigenvectors will be like this. पहले आप compute करो lambda I minus a. Then you compute adjoint of lambda I minus a. But since you are interested in only one, and we have seen that its columns will be linearly dependent. Its columns will be linearly dependent. If I have said linearly independent in the beginning, I'm sorry for that. Its columns will be linearly dependent. So any particular column of this matrix adjoint of lambda I minus a will actually be the eigenvector. So if you compute adjoint of lambda I minus a, so it is not necessary to compute this complete matrix. You can compute only one column. You can even compute only one column of this matrix. And then what you do is you substitute lambda 1, lambda 2, जितने भी eigenvalues हैं, for lambda 1 by 1. And get the corresponding eigenvector. I'll show you the procedure. Get the corresponding eigenvector. See, I'll show you how. We'll take some example and I'll show you how this method can be used for evaluating computing the eigenvectors of a matrix.
पूरा थोड़ा सा ब्लर आ रहा है.
Blur आ रहा है? Right signal. I found you the वीडियो ब्लर आ रहा है क्या?
Yes, sir.
अभी देखो. Let's check once again.
सर अभी भी आ रहा है.
वीडियो ब्लर ही आ रहा है.
Yes, sir.
Any improvement? कुछ सही हुआ क्या?
No, sir.
Still blur, huh?
वो किसी ने उठाया हमसे मैनेज Adamın kontrolü bir çeşitli bol olmuyor. Bunun kodu belirleyeceğim. Hangi yüzüme düşmüşsün sunayım. Maximum number of functions they want to present. और function is equal to initialize. कुछ आइटम की जो कि माइनर पेमेंट को दो कर दिया है जो मॉडर्न्स में किस तरह से नहीं रहता अगर तुम उस एडवांस में चेक करो उन्हें स्विच डालेंगे ऐसी कैसा बुलाकेट करा मैनेज करते हैं किधर से माइनर do atleta bom, você for de copo de você
Just wait a while. You are just trying to rectify the problem.
अच्छा अभी हो गया अभी लैपटॉप का इशू आ रहा था अब कर रहा है वो स्टार्ट किया उसने स्टार्ट चला पूछिए इनको अब आ रहा है ठीक
अब देखो आप
सर आ रहा है
सर अब ठीक है
आप ठीक है ना?
yes.
So this is some scan matrix A, and we have to compute the eigenvectors for this matrix A. Okay. We have to compute, let's say, eigenvalues and eigenvector. बताओ कैसे करेंगे सॉल्व इसको पहले हम इसके आइगन वैल्यूज हमने ऑब्टेन करने हैं Can you recognize any form for this matrix A? तो इसका characteristic equation क्या होगा? Shall we determine the lambda I minus A equal to 0? बताओ मुझे इसका characteristic equation जल्दी से बताओ obtain the characteristic equation of this matrix A. Yes, are you doing? हाँ जी कर रहे हो आप? What will be the characteristic equation of this matrix A?
Sir, lambda square minus 17 lambda minus 24 equal to 0.
लैम्डा स्क्वायर कहाँ हो गया तो लैम्डा क्यूब होगा। ये क्रॉस मैट्रिक्स है ना?
So lambda cube plus 9 lambda square,
ओके
9 lambda square plus 26 lambda plus 24.
इज इक्वल टू 0। अब इसको सॉल्व करके बताओ इसके आइगन वैल्यूज क्या होंगे। यस
-2, -3, -4.
हाँ are you obtaining the eigenvalues?
चल रहा है
Are you obtaining the eigenvalues?
Sir, -2, -3, -4.
Lambda 1 is -2, lambda 2 is lambda 3 is -2. Okay, so these are the eigenvalues. Now we have to compute eigenvectors. Eigenvectors के लिए मैंने क्या प्रोसीजर बोला आपको? पहले हम करेंगे lambda I minus A matrix evaluate. So this is like this. This is lambda 0 0 0 lambda 0 0 0 lambda minus -9 -26 -24 1 0 0 1 0 0 and 0 1 0 0 1 0. This will be lambda plus 9, lambda minus 1, no, minus 1, not lambda minus 1, then 0. That will be 26.
-1.
Yes?
Second element
Minus 1. Okay, minus 1. Huh? So this is 26, then it is lambda. Then it's -1. That's 24. Then 0. And lambda. Is that okay? Next step क्या है फिर? इसका adjoint obtain करना है. Next step is you have to obtain adjoint of lambda I minus A. जैसे मैंने कहा ये पूरा मैट्रिक्स इवैल्यूएट करने की जरूरत ही नहीं है. हम क्या करेंगे? हम खाली इसका एक कॉलम ऑब्टेन करेंगे. Adjoint of lambda I minus A. We'll get only one column. So for getting the first column, actually we will obtain the cofactors of, because adjoint obtain करने में you later on have to take the transpose. So we'll obtain the cofactors corresponding to this particular row, and then become the column of this adjoint matrix. Let me tell me what will be the first entry in this. Yes. Tell me what will be the first entry in this.
lambda square.
Lambda square. Okay, second entry. This particular entry को पता जल्दी. -26 lambda -26 lambda and -24, isn't it? सही है?
Yes,
And
sir.
this
Yes, sir.
particular- What will be the third entry? Third entry
Minus
will be
24 lambda.
minus 24 lambda. Very good. Okay. तो बाकी एंट्रीज इसकी ऑब्टेन करने की जरूरत नहीं है because they'll be linearly independent columns. So I don't need to evaluate the other entries. Now what will I do? I'll just obtain adjoint of lambda 1 I minus a. Lambda 1 is minus 2. What does that become? So lambda 1 is, as you know, lambda 1 is minus 2. I'll substitute it here. So this will become 4. Isn't it? So this is 52 plus 24. How much is that? 52 minus 24, it's 28. Okay. And then minus 24 lambda. This will become 48. Is that okay? Other entries will be like this. ठीक है? इसमें अगर मैं 4 बाहर भी निकालूं, I can take that common. I'll take it in what we call lowest form. It will become 1, 7 and 12. 1, 7 and 12 ये आपका adjoint matrix होगा. इसमें और भी 2 columns होंगे. लेकिन आपका जो VI है, VI, which is actually proportional to this adjoint of lambda I minus a. So VI will be equal to 1, 7 and 12. Is that procedure okay? Is that okay?
Yes, sir.
Okay. अब फिर क्या करेंगे? अब दूसरे आइगन वैल्यू के लिए निकालेंगे. दूसरा आइगन वैल्यू क्या है? So now I will evaluate adjoint of lambda 2 I minus a. And lambda 2 you know that is equal to minus 3. Isn't it? So this will become adjoint of lambda 2 I minus a will become equal to. So you substitute lambda 2 equal to minus 3. Lambda 2 is equal to minus 3, so this will become 9.
Now 54.
दूसरा क्या आएगा?
54.
54. Minus 54 or 54? 54. And the third one will become 72, isn't it? It will be like this, like this. तो इसको भी अगर हम कॉमन निकालें, it will become 1, 6 and 8. So VI will be equal to, sorry, this will be V2. यहाँ पे V1 है, ये V2 होगा. So that will be equal to 1, 6 and 8. ठीक है? So this is your V2. Similarly, we will obtain V3. We will evaluate adjoint of lambda 3 I minus a. And lambda 3 is how much? Minus 4. So once you do this, tell me what will this be? This will come out to be, yes, 16, 80 and 96. So V3 will actually be proportional to this. That's equal to 1, 5 and 6. Is that okay? तो 3 आइगन वेक्टर्स मैंने ऑब्टेन कर लिए. Is the procedure okay?
Yes, sir.
Okay. तो अब मुझे क्या करना है? मुझे बेसिकली आइगन वेक्टर्स तो मैंने इवैल्यूएट कर लिए. अब मैं इन आइगन वेक्टर्स को यूज करके आपका जो मैट्रिक्स ए है उसको डायगोनलाइज करूंगा. उसके लिए क्या प्रोसीजर है? I'll first frame matrix P. So we'll first frame matrix P. Matrix P is defined like what? It's equal to, it's V1, V2, V3. eigenvectors stacked together as columns of a matrix. What is V1? V1 is 1, 7 and 12. And V2 क्या है? 1, 6 and 8.
6, 8.
And V3 is 1, 5 and 6. Isn't it? तो डायगोनल फॉर्म में कैसे रिप्रेजेंट करते हैं? डायगोनलाइज्ड जो मैट्रिक्स करते हैं डायगोनलाइज, तो वो कैसे वो कैपिटल लैम्डा से हम रिप्रेजेंट करते हैं? दैट्स इक्वल टू P इनवर्स ऑफ AP. Isn't it? तो पहले हमने इस मैट्रिक्स P का इनवर्स ऑब्टेन करना है. बताओ मुझे इसका इनवर्स क्या आ रहा है? Just invert the matrix P. Just invert the matrix P. तो मुझे बताओ कि इनवर्स क्या आ रहा है इसका? जल्दी से. Don't we have the calculators with you? इतना टाइम लगता है क्या मैट्रिक्स को रेट करने में?
Sir, 2 minus 1, 1 by 2,
2
minus 1,
minus 1,
1 by 2,
okay,
minus 9, 3,
minus 9, 3,
minus 1,
minus 1,
8,
8,
minus 2, 1 by 2.
minus 2, 1 by 2. Let somebody else confirm whether it's correct. I think it's okay. This is your P inverse. अब मैंने ये लैम्डा ऑब्टेन करना है. That's P inverse of AP. So this is your P. 2 minus 9, 8 minus 1, 3 minus 2, 1 by 2 minus 1, 1 by 2. I have to perform the operation P inverse of AP. So this is P inverse. Then A is what? A is minus 9, minus 26, minus 24. Then 1, 0, 0, 0, 1, 0. And then you have A. Sorry, P. What is P? P is 1, 7, 8, 1, 7, 12, 1, 6, 8, and 1, 5, and 6. और एक प्रोडक्ट को बताओ मुझे कितना आ रही है. बता जल्दी से. this matrix multiplication and tell me what is this delta matrix coming out to be. हाँ जी मल्टीप्लिकेशन नहीं आता क्या
Sir, -200
-2 0 0
0 -30
ओके
0 0 -4.
0 0 -4 हो गया ना डायगोनलाइजिंग और डायगोनल पे क्या है इंक्रीज डायगोनल पे आइगन वैल्यूज आ गई so your matrix A has got diagonalized when you perform the operation P inverse of AP is that okay do you now understand how to diagonalize the matrix how to compute the eigenvectors क्योंकि eigenvectors compute करने का issue जो है it's a mathematically involved problem so now can you evaluate the eigenvectors now for any matrix
Yes, sir.
लेकिन हम वो आपको याद रखना है कि हम वो वाला केस कंसीडर कर रहे हैं जिसमें कि आइगन वैल्यूज डिस्टिंक्ट हैं खाली उसी केस में आप मैट्रिक्स को कंप्लीटली डायगोनलाइज कर सकते हो नाउ व्हेन यू डायगोनलाइज द मैट्रिक्स नाउ टेल मी हाउ विल यू इवैल्यूएट e to the power 80 evaluate e to the power 80 using this concept of eigenvalues and eigenvectors so last time हमने क्या प्रूव किया था e to the power 80 is equal to what yes tell me in terms of e to the power lambda t what is e to the power 80 equal to in terms of e to the power lambda t आपको याद है
P e to the power lambda t
yes
inverse. P e to the power lambda t into
p
P
e to
inverse.
the power yes p e to the power lambda t p inverse है ना तो p हमने ऑब्टेन कर लिया p इनवर्स भी आपको पता है e to the power lambda t क्या होगा e to the power lambda t will be because lambda is this is a diagonal matrix so e to the power lambda t will be e to the power minus 2t 0 and 0 0 e to the power minus 3t and 0 and 0 0 e to the power minus 4t multiplied by p inverse isn't it are you getting me
Yes, sir.
so p you already know p inverse also you have evaluated tell me what will be e to the power 80 in this case योर पी इनवर्स पता है ना आपको ये आपका पी है ये आपका पी इनवर्स है दिस इज योर पी एंड दिस इज पी इनवर्स just evaluate it and give me the final answer
नहीं किया था ऑटो एडमिट
जल्दी से Have you done it? ये हो गया कि नहीं? Can you hear me?
Yes, sir. Answer both number.
हाँ, लंबा है बहुत. ठीक है, आप कर लोगे, isn't it? You can do it now.
Yes, sir.
Okay, just try. Just do it at your places. So just try doing it at your places. It's not difficult. You just have to do the matrix multiplication. So this finishes our topic computation of eigenvectors. But we'll have to do some. Actually, this finishes the topic computation of state transition matrix, and we have learned 3 methods to evaluate the state transition matrix. One method was using Laplace transform. Second method we have learned using Kelly-Newton theorem, and third method we have learned using similarity transformations, wherein we transform the matrix first to diagonal form, and then obtain the state transition matrix by using this formula. Are all these methods clear to you?
Yes, sir.
Okay. अब हम क्या करेंगे? अब we'll also solve some numericals, wherein we will solve the complete state equation. जिसमें कि input भी दिया हो और initial conditions भी दी हुई हो. For a given input and for the given initial conditions, we actually will be solving the non-homogeneous state equation. Do you understand what I am saying? आपने स्टेट मॉडल दिया हुआ है, that is x dot equal to ax plus du, y equal to cx plus du. तो ये कंप्लीट स्टेट मॉडल है और इसमें x नॉट भी दिया हुआ है. This is also given, and let's say input is also given, ut is also given. And you are asked to solve the state equation, and maybe after that you may also have to find the output. तो उसके लिए क्या हमने देखा? What is the formula for that? xt is equal to what? e to the power at x naught plus integral of 0 to t e to the power a t minus tau b u tau d tau. ये फॉर्मूला हमने प्रूव किया है ना? तो हमने देखा कि इस सॉल्यूशन के दो पार्ट्स हैं. One is this part and second is this part. This part is known as what? It's the natural or free response. It doesn't depend upon the input or the forcing function. And this part is what's known as the forced response. इनपुट पे भी डिपेंड करता है और सिस्टम मैट्रिक्स पे भी डिपेंड करता है. अगर आपको ए बी सी डी दिया हुआ है और आपको कहा जा रहा है कि स्टेट इक्वेशन सॉल्व करो और बाद में आउटपुट भी ऑब्टेन करो, तो स्टेट इक्वेशन और आउटपुट इक्वेशन आपने सॉल्व करनी है. तो उसके लिए आप क्या करोगे? पहले स्टेट ट्रांजिशन मैट्रिक्स इवैल्यूएट करोगे. स्टेट ट्रांजिशन मैट्रिक्स इज e to the power at, and I have told you the methods of evaluating the state transition matrix. Any method that you are comfortable with, you can use that method to evaluate the state transition matrix. And this part you will obtain because x0 is given, then e to the power 18 into x0, you will get the natural or free response. Now next is to obtain the forced response. From this e to the power 80 that you have obtained, you will also obtain e to the power 80 minus tau. And then multiply it by b and u tau and integrate it. ये matrix होगा actually. तो matrix के अंदर जो सभी terms हैं उनको integrate करना पड़ेगा. And that will give you the forced response of the system. And the total response of the system will be e to the power 80 x naught plus integral of 0 to t e to the power 80 minus tau b u tau d tau. Is that clear? Is that clear or not?
Yes, sir.
अब अगर हम एक एग्जांपल लें, मान लो आपको ए दिया हुआ है, स्टेट स्पेस मॉडल है जिसमें कि ए है -1 1 -1 एंड -10, B is 0 and 10, and C is 1 and 0. मॉडल कुछ ऐसा है, x dot equal to ax plus bu and y is equal to cx. B is not there. The initial conditions are given as, that is x0 जो है x0 is given as zero and 1. Okay. And the input is a unit step function. Ut is 1. You have to evaluate xt and yt. xt and y. तो बताओ कैसे करेंगे? पहले हम फॉर्मूला लिखेंगे xt की, सॉल्यूशन की, that is e to the power 80 x naught plus integral of 0 to t e to the power a t minus tau b u tau and d tau. ut 1 के बराबर है, सही है ना? तो पहला स्टेप जो आपका इसमें होना चाहिए, that should be you should be evaluating e to the power 80. That is the state transition matrix. तो state transition matrix को evaluate करने के मैंने आपको different तरीके बता दिए. Any method you can use, any method you are comfortable with, whether Cayley-Hamilton method or state transition or the similarity transformation method or Laplace transform method to evaluate this e to the power 80. Are you following me?
Yes, sir.
So if you evaluate this e to the power 80, so you will once you will evaluate this and then multiply it by x0, you will get this portion of the response. सही है ना? अगर इस केस में मैं आपको बताऊं ये जो e to the power 80 है, if you evaluate it, it's coming out to be 1.0128 e to the power minus a1t minus 0.0128 e to the power minus a2t, and 0.114 e to the power minus a1t minus 0.114 e to the power minus a2t. This is minus 0.114 e to the power minus a1t plus 0.114 e to the power minus a2t minus 0.0128 e to the power minus a1t and plus 1.0128 e to the power minus a2t, where a1 is equal to 1.1125 and a2 is equal to 9.8875. So can you obtain this e to the power 80? Any method, whichever you want to use, you can use that method to evaluate e to the power 18. It comes out to be something like this. Can you do it and evaluate it? इसमें कोई प्रॉब्लम है आपको e to the power 80 evaluate करने में?
No, sir.
You'll be able to evaluate it, isn't it?
Yes, sir.
Once you evaluate e to the power 80, then multiply it by x0, which is actually 0 and 1. You will get this part of the response, isn't it? अब बचा ये वाला हिस्सा response का. That is integral of 0 to t e to the power at minus tau b u tau d tau. What is b equal to? First we have e to the power at minus tau. That is this. e to the power at minus tau आपका ये है. इसको क्या करना है? b से मल्टीप्लाई करना है. ut तो 1 है. It's to be multiplied by b. तो यहाँ पे b वाला मैट्रिक्स आएगा. b वाला वेक्टर आएगा. What is b वेक्टर? b वेक्टर 0 and 10.
0, 10.
0 and 10. ठीक है ना? ये बन गया आपका e to the power atb. सही है? So once you multiply it with 0 and 10, you will end up with a vector. Always that vector, because when you multiply this by 0, this becomes 0. So actually this column will get multiplied by 10. So it will be like this. 10 into this. So this becomes 1.14 e to the power minus a1t minus 1.14 e to the power minus a2t. Then when you multiply this by 10, this becomes minus 0.128 e to the power minus a1t plus, yes, 10.128.
128, so 10.128.
e to the power minus a2t. सही है ना? ये निकला ये वाला हिस्सा. लेकिन इसमें e to the power at minus tau है. So this is actually e to the power a t minus tau. सही है ना? e to the power a t minus tau into b. तो जहां जहां पे t है वहां पे t minus tau आएगा. Are you following me? जहां जहां पे t है वहां पे t minus tau आएगा. So this will be t minus tau, this will be t minus tau, this also will become t minus tau, this will become t minus tau, this also will become t minus tau, and this also will become t minus tau. और यहाँ पे भी ये वाला जो है, this will become t minus tau, this will become t minus tau, here also this will be t minus tau and t minus tau. Are you following me? Is that clear?
Yes, sir.
मैं एक्चुअली ये इवैल्यूएट कर रहा हूँ e to the power a t minus tau, b से मैंने इसका मल्टीप्लाई कर दिया. u tau 1 है, isn't it? Now I have this integral. I have to integrate this d tau from 0 to t, isn't it? तो हर एक टर्म जो इसकी है वो इंटीग्रेट हो जाएगी, ये वाली टर्म भी इंटीग्रेट हो जाएगी फ्रॉम 0 to t, और ये वाली टर्म भी इंटीग्रेट हो जाएगी फ्रॉम 0 to t, and this will be d tau here, and this also will be d tau here. Are you getting me? Is that okay? So do you know how to perform the integration? This is to be integrated with respect to tau, and then you have to give the limit 0 to t, here as well as here. So once you do that, you will end up with some term here, some term here. So that will give you this portion of the response. ये वाला पोर्शन ऑफ रिस्पांस आपने ऑलरेडी ऑप्टेन कर लिया है, इन दो को ऐड करके आपको xt मिलेगा. Do you follow the procedure? Did you understand how to do it?
Yes, sir.
Okay. फिर एंड में आपको इसका आउटपुट भी ऑप्टेन करना है. जब x किया ऑप्टेन, you have to multiply this x, re-multiply it by c, and you will get 1. अभी ये न्यूमेरिकल करो आप try. I'll be leaving the meeting, but all of you just continue with this. Do the numerical because I have to go for some meeting, and the meeting is incidentally in this room only. So you just continue this numerical and show it to me tomorrow. Is that okay? Complete solved numerical you will show to me tomorrow. Okay, I'll ask any random student to show me what is the how have you actually done this numerical. If you have any problem, you can just tell me this time. कहीं पे अगर समझ नहीं आया या कुछ प्रॉब्लम है इसमें, you can just tell me this time. Yes. Is the procedure clear?
Yes, sir.
Okay, so just do this numerical and show it to me tomorrow. This time we can leave the meeting.